Welcome everybody to today's webinar on accelerating 5G impact through cell site backhaul automation. As a quick introduction, my name is Morgan Stern. I'm the Vice President of Automation Strategy at Itential. I work closely with many of our communication service provider customers on transforming their engineering and operations through automation. Also on the call is Karan Munalingal. He's our head of pre-sales engineering. During the session, Karan will be demonstrating some of the automations that are part of our IP backhaul solution. Today's webinar is focused on the critical role that the IP backhaul network plays as an enabler for key 5G capabilities, such as virtualized RAN, closed-loop operations, and network slicing, and on how automation can not only significantly reduce the cost to deploy and operate the backhaul network elements, but also how it can become an accelerator for other 5G technologies and features. Before we get started, here are a few housekeeping points. First, everyone on the call will be muted. We're going to reserve answering any questions until the end of the presentation, but please ask your questions along the way by adding them into the questions panel, which you'll find under the webinar. If we don't get to all the questions on the call, we'll answer them via email shortly after the webinar. So now let's get started. In today's session, we'll be looking at the changing landscape of the IP backhaul network, from its origins as a relatively basic architecture to today's more heterogeneous model driven by the introduction of technologies such as CPRI, small cells, virtualization, and MEC. We'll talk about how these technologies have created new demands on backhaul engineering and operations teams, as well as other drivers for automation and orchestration in the transport network. Next, we'll talk about the phases of automation that we've been seeing in the CSP space and how we've been working with our customers to evolve through these phases and to improve capabilities and efficiencies. Then, we'll cover the top use cases for automation of the IP backhaul network elements, from initial deployment through operations and on to enablers like network slicing and closed-loop automation. After that, we'll take a look at the results of a recent project where our team worked with the CSP to calculate the business impact of their cell site router automation project so they could quantify the benefits that the project has delivered to their business. We'll also review some of the key metrics for IP backhaul automation projects. These are metrics that can be useful to define targets and to measure against them during and after the introduction of the automations. We'll wrap up the presentation with a discussion on how cell site backhaul automation can become an enabler for 5G capabilities. After the presentation, Karan will walk us through a demonstration of some of the cell site router automation use cases to showcase how the Itential platform delivers value. While the continued explosive growth in mobile data volumes has prompted many service providers to upgrade their backhaul networks, there are a number of other factors that are driving changes in the mobile network environment, including 5G throughput and latency demands, expansion of the access network sites, and this is both macro and small cell sites to provide coverage and density for high-speed access methods such as millimeter wave, increasing demand for hybrid cloud and multi-cloud access at the edge, IoT growth and growth in fixed wireless subscribers, interest in 5G network slicing and the need to support transport network slicing functionality, and RAN disaggregation, along with the introduction of technologies like Open RAN and virtualized RAN elements. Before we discuss backhaul automation, I wanted to clarify what we're referring to when we use the term backhaul in this context. Historically, the backhaul network included all of the elements that carried mobile traffic from the cell sites into the mobile core network. This could include elements such as optical transport, microwave, Ethernet, or TDM elements. Increasingly, As mobile data has grown in volume and importance, IP and Ethernet has become much more prevalent. For this session, we'll be focusing on these IP elements. The IP portion of the backhaul includes the cell site routers. These are the routers that are deployed at the cell sites and that are connected to the mobile radio nodes, as well as the aggregation routers. These are the routers that are deployed to hub sites and provide a hub connection point to multiple cell site routers. The cell site routers transmit IP traffic to the hub aggregation routers, which in turn route traffic into the mobile packet core. In the 4G architecture, each LTE site has a radio base station called an eNode B. Each eNode B is connected to a cell site router, which is then connected via an IP circuit to an aggregation router at a regional hub site. Advances in transport technologies and new capabilities in the 5G architecture have created several new options in the backhaul environment. These changes fall into a few different categories. First, distributed RAN functionality, such as Open RAN or ORAN, which focuses on virtualization and disaggregation of the eNode B functionality into CU, DU, RU functions, so they can be deployed in a distributed model and enable mobile operators to optimize function placement for performance and cost. Additionally, front haul technologies, including introduction for options for front haul and mid haul by leveraging technologies like CPRI, the Common Public Radio Interface, and fiber to enable centralization of eNode B assets that had previously been required to be co-located at the cell site due to latency requirements. Finally, the growth and deployment of small cells to augment macro network coverage have changed the ways folks are doing backhaul. These technologies create opportunities for carriers to cost optimize their backhaul networks while still providing options for low latency, high performance communications. Mobile operators can design their networks to take advantage of cloud technologies, virtualization, and merchant silicon hardware. With options, however, comes complexity. The topology of the backhaul network is changing from a simple hub and spoke model to a potentially much more diverse model, with elements like virtualized RAN being distributed at multiple sites, or technologies like CPRI creating additional links in the end-to-end communication path. This complexity creates an opportunity for CSPs to leverage automation to mitigate the additional engineering effort that technologies like ORAN, CPRI, and virtualized routing introduce. In our work with CSPs globally, we've seen a number of different approaches related to deployment, configuration management, and configuration compliance for the IP backhaul network elements. In general, these approaches fall into three categories or phases, with each phase introducing more sophistication in terms of capabilities and commensurate benefits. Phase 1 is task automation with scripts. And this is where most automation journeys begin with, where folks are doing scripting using Shell or Python scripts with a focus on automating specific tasks. For example, if the engineering team needs to change the NTP server address on every one of their cell site routers, they would make a Python script that would connect to each router, change the NTP server address, and move on to the next one. Scripting is very powerful for task level automation, so it's useful at the individual engineer level for their ability to improve their own productivity. However, the limitations of scripting become more apparent as teams attempt to scale up, either by exposing the scripts to a larger audience and by trying to automate more complex activities with scripting. Neither of these scenarios are working very well. In the first case, sharing scripts with other members of the team requires training, version control, and care for usability factors such as code commenting and documentation. In the second case, where engineers attempt to automate complex activities with scripting, the overhead associated with maintaining the code base becomes overwhelming, and scripting typically hits a ceiling with respect to scalability. Nevertheless, in some situations, it can be extremely valuable. Phase 2 is process automation. In the second phase of the automation journey, the focus shifts to evolving from a task-centric automation mindset to process-centric automation. This typically requires more sophisticated tools, but the business benefits are significantly better than task-centric automation for a few reasons. First, process-centric automation includes more activities within the automation scope. The more activities that can be automated, the more manual activity and effort can be pulled from the process, and more idle time can be removed. This results in faster execution of the business process with less effort. Using the example from above, while the task-focused approach is really focused on automating the change itself, a process-focused automation approach would include all of the steps prior to and after the change. So in a process-centric model, the automation system would collect all of the variables to be changed from destination systems and network elements. Then it would create a list of target routers. Then it would perform the desired changes, then perform health checks after the change was made to ensure that the routers are still operating properly. It may even do things like make a call to an external test system or service assurance platform to confirm that the operation was successful. The process-focused approach not only automates each step, but it eliminates any idle time between steps, so the changes can be performed more rapidly, with more accuracy, and less manual effort. Phase 3 is closed-loop and machine-to-machine automation, and this phase focuses on exposing the automation system's capabilities to external teams and systems. So instead of a human being the initiator of the automation activity, the automation platform is able to receive triggers from systems or from the network itself. There are a wide range of scenarios where this can have a transformative impact on engineering and operations activities. For example, the automation platform could be configured to listen for DHCP requests from newly connected devices and perform a complex configuration of the device to enable it to participate in network service delivery. Alternatively, the automation platform could be configured to perform closed-loop activities as described earlier. In this phase, the business value of the automation efforts goes up significantly as the volume of activity and subsequently the value delivered can go up at a much faster rate due to the activities not requiring any interventions from engineering or operations to execute. We'll show an example of a closed-loop activity in the demo portion of this session. One of our goals at Itential is to help CSPs realize the benefits of moving towards Phase 3 as quickly and as efficiently as possible by providing tools and a platform that make it easy to do the level of integration and exposure that's required for Phase 3. Now let's talk about the most high-value use cases for the automation of IP backhaul elements. The key cases that are emerging for IP backhaul automation fall into three categories. In implementation, the use cases include installation and configuration of new cell site routers or aggregation routers. It includes capacity addition for activities like physical upgrades, bandwidth upgrades, and circuit and traffic migration. Implementation use cases can take advantages of capabilities like zero-touch provisioning to enable fully automated configuration of the new cell site routers or aggregation routers. In this scenario, the automation platform is integrated with engineering databases, inventory databases, and the DHCP environment to enable auto detection of new devices, along with deployment of a gold standard configuration that can be augmented with device-specific variables provided by the engineering and inventory databases. Capacity additions and migration activities are happening with greater frequency as a consequence of 5G rollouts. with activities that can be automated, including things like provisioning of the cell site and aggregation routers to support the capacity change, and coordination and orchestration between the IP device configuration changes and changes to the underlying transport, such as the optical links or other physical layer changes. Operations use cases include automation of the activities associated with ongoing health and operation of the IP backhaul network, such as IP backhaul device upgrades, configuration compliance, device health checks, maintenance window automation, fault triage, and break-fix configuration activities. Automation of these activities allows operations teams to perform significantly more activities with significantly less manual effort, enabling them to improve network reliability and performance in multiple ways. First, by replacing manual keyboard inputs with automated changes, accuracy improves dramatically and eliminates outages caused by incorrect inputs. Next, operations can automate activities like health checks and pre-post checks, enabling them to perform sophisticated checks in seconds instead of hours. This allows them not only to automate the checks that they were previously performing, but perform more checks than would have been normally able to do due to time constraints. This is improving accuracy and confidence that their changes will not cause inadvertent disruptions. Additionally, the operations teams can capture all of the data associated with the execution of automated activities in an operations database, which can be analyzed by machine learning systems to further improve quality and performance. Operations teams can begin to use this data to implement closed-loop automation use cases for triage and resolution of network errors. 5G service enablement use cases are related to configuring and implementing the IP backhaul devices to support or to improve support for advanced 5G functionality, such as 5G network slicing and MEC use cases. This topic will be explored in more detail later on in this presentation. Given the large number of IP backhaul devices currently deployed and the maturity of the engineering and operations activities related to those devices, mobile operators have a reasonably comprehensive understanding of the costs and resources required to deploy and operate the IP backhaul network. This makes the backhaul network an ideal candidate for being able to define and quantify the business impact and benefits for automation. Based on our work with automating IP backhaul network elements for two of the largest mobile operators in North America, Itential has developed a comprehensive business analysis model that has identified the following areas as major drivers for business value. First is reduction in manual effort. So whether the use case is IP backhaul implementation or operations, automation drives significant reduction in manual effort. In multiple deployment projects, automation has shown to reduce manual effort for cell site router and for aggregation router installation and configuration by more than 50%. For operations use cases, automation has been able to reduce manual effort by more than 90%. Second is reduction in process duration. Another area that's been particularly important for 5G programs is the ability for automation to reduce the end-to-end duration of a business process or project. Operators who have used automation as part of their upgrade initiatives have been able to eliminate project backlogs and accelerate project timelines, giving their project managers the ability to deliver key capabilities well in advance of deadlines. The downstream impact of accelerating IP backhaul projects is a significant benefit to the other parts of the business, enabling leadership to move forward on activating new features and capabilities that have the potential to drive new revenues, such as 5G slicing. Third is increases in engineer productivity. There's been several ways that IP backhaul automation has increased engineer productivity. For example, by automating time-consuming activities like health checks, engineers can perform more activities in each maintenance window. Additionally, by using automation to execute multiple activities in parallel instead of a normal serial approach, engineers can perform more iterations by a large factor. In one real-world example, engineers that could only manually perform 2 upgrades in a 5-hour maintenance window were able to perform 100 automated upgrades in that same 5-hour window. Fourth is the ability to free up engineering resources from repetitive simple tasks. Once the simple but time-consuming tasks like health checks are automated, engineers can use their time to focus on activities and initiatives that drive greater business value. Time is freed up to allow the engineers to work on strategic projects and deploy new functionality, new vendors, and new capabilities. Now let's talk about some of the key metrics. On a recent IP backhaul project, the Itential team performed a detailed analysis to calculate the business impact of automation using 2 key metrics. The first was workload unit cost, or WUC, and engineer productivity. During this analysis, Itential engineers worked with the mobile operator to identify and qualify all of the activities related to their manual processes for cell site router deployment, upgrades, and config management. A number of these activities also utilized scripting to automate specific tasks, but fell short of full process automation. The team also utilized data from previous projects to quantify the efficiencies of performing the same activities with full process automation. For deployment-related activities, workload unit costs decreased between 50% and 67%, while the workload unit costs for operations tasks decreased by 70% to 90%. For those same sets of activities, engineer productivity improved by 300% for day 1 activities, which is deployment configurations, and by 600% for upgrade activities. As part of the business analysis, the team looked at multiple scenarios, ranging from extremely conservative to more aggressive. In all cases, the resulting cash flow from the reduced effort was positive, and in most cases, the payback period for implementing a comprehensive automation program for IP backhaul was below 9 months. In the average case, payback was 6 months, with the use cases that drove the most significant savings being device upgrades, device compliance, and maintenance of automation windows. Now let's talk about enabling 5G capabilities. While the business case for IP backhaul automation is extremely positive based on the efficiencies gained through automation of deployment and day-to-day operations, one of the major technical benefits that automation provides is its ability to support new 5G capabilities and features such as network slicing. The IP backhaul network is a component of the transport network, the TN, which is one of the 3 networks, the slicing domains in the 3GPP model, the others being RAN and mobile core. Within the 3GPP network slicing specification, the TN's involvement in network slicing is primarily related to ensuring that the network can meet the technical requirements for each network slice, particularly in the areas of latency, bandwidth, and traffic isolation. The network slicing architecture identifies controllers which perform the network slice subnet management function for each of the domains, including the transport network domain. The primary requirements for the TN NSSMF are that it can dynamically configure the transport network components to create the quality service and VPN features required by each network slice, and that it can expose the ability to manage the TN elements to a higher layer cross-domain controller called the Network Slice Management Function, NSMF. An IP backhaul automation system can act as the NSSMF or in coordination with another TN NSSMF if it has the ability to work real-time and can configure and manage the IP backhaul network elements to create the network slice configuration components that conform to the network slice profiles defined by the operator. It can also support closed-loop operations for slice-related and non-slice-related operations. In June, we demonstrated some of these capabilities in a joint webinar with Calum and Equinix. We see that automating the IP backhaul network creates significant opportunity for the IP transport teams to participate in providing more value to the operator and to its customers. So when an automation platform can expose more functionality to other orchestrators and controllers, the network can deliver more responsively and can offer higher value capabilities. Let's talk about the steps required to evolve to full automation. I want to highlight the process that we recommend for CSPs for implementing a more comprehensive solution. First, you need to identify what you want to automate. This includes the network elements, the vendors, the quantities of devices, and the high-level use cases that you want to include in your automation initiative. An example of a use case may be Nokia cell site router installation for a deployment team, or a maintenance window configuration change on an aggregation router for the ops team. Next, you need to identify the current model. This includes the processes, tools, people, and systems that are involved in the current operating model. The key data points include things like what teams are involved, how much time does each step take, what are the sources of data for the activities, what are the tools that they currently use, and then what vendor components do they need to interact with. Next, need to prioritize the use cases based on their business priorities, focusing on the cases that have the greatest impact on project timelines and operating costs. Once you've prioritized the cases, you can deploy the automation platform and integrate it with the data sources and develop the automations for the use cases based on priority. During this step, it's useful to focus on developing modular components that can be used across multiple use cases. Finally, once the system is deployed, you can monitor the system and optimize the automations to achieve greater efficiency. Before we show you the demonstration of Itential's IP backhaul automation solution, I'd like to quickly review what's in the solution. The technical team at Itential has created a bundle of software and automations that are specifically targeted to address the highest impact use cases related to cell site and aggregation routers. The solution comes with the Itential automation platform, which is the automation server itself, along with pre-built automation building blocks that address deployment, configuration compliance and remediation, device upgrades, maintenance window automations, and automations for creating and managing functionality like VPN and QoS. By combining the platform with the pre-built components, Itential users can immediately dive in and start to automate their backhaul network elements. We've seen customers begin to get value from the system within days by leveraging the rapid integration capability of the platform and native functionality like the golden configuration module of Configure Manager to perform compliance checks and remediation. Now I'd like to hand the session over to Karin Munalingel, our head of sales engineering. Karin's going to demonstrate how the Itential solution is automating a wide range of IP backhaul use cases for a number of Tier 1 service providers today. As a reminder, if you have any questions, we'll have time at the end of the session. Please ask your questions by typing them into the questions panel, which you can find at the bottom of your control panel. Okay, Karin, take it away.
Thank you, Morgan. Hello, everyone. I'm Karin Munalingel, and I will be demonstrating how Itential's out-of-box pre-built automations and platform capabilities will enable organizations to achieve IP backhaul automations at scale. As part of the demonstration today, we will look at how backhaul teams can leverage Itential's pre-builts to rapidly create new networks by onboarding backhaul assets in an autonomous manner. Once the CSR, ag routers, or even packet core functions are onboarded, we will show you how teams can identify and define golden configuration as well as best practice policies for all these network elements in order to drive compliance across the IP backhaul network that might resonate and reside within multiple markets and regions. The last part of the demonstration will focus on closed loop automation, how Itential enables our customers to not only automate day zero, day one, but also day in operation in a closed loop fashion. So once all the assets are actually onboarded, the next normal thing to do would be to establish, monitoring and service assurance services that will tell the customers, how the actual backhaul network is operating, right? So in this case, what we're going to do is, as part of the demonstration today, we're going to leverage Zabbix as a way to monitor one of the cell site routers, and we're going to invoke a change within the cell site router to bring a port down, which will actually invoke an event within a Kafka bus, off of which the Itential automation platform will react to it and invoke a RCA or remediation automation to actually address that within the network. right? So from a demo architecture perspective, as you see on the right-hand side, Itential Automation Platform is where we're going to be leveraging the pre-built automation to perform all the network changes, as well as, our communication with the various different types of orchestrators and controllers, but also our ability to leverage Itential Automation Gateway to talk to these network assets via netconf, etc. Right? So with that, what I would like to do is jump right into the system in order to showcase our capabilities around IP backhaul automation. All right. So now that we're within the Itential Automation Platform, the three primary applications that we're going to see today is the Admin Essentials, where our network engineers and backhaul team members will be able to interface and interact with our pre-built automations and administrative platform. The second application we're going to look at is Automation Studio, which is where you use the low-code drag and drop capability to address and also enhance some of these pre-builds that are out of box, that you can operationalize in a rapid fashion within your environment. And the last thing we're going to head on today is Configuration Manager, which is where, Itential practices the concept around federating, your network within a single pane of glass, but also enable you to define the gold standard configuration that would apply across your network, right? Not only for your CSR routers, but within the ag routers, as well as the core packet core functions. So let's get started. The first thing we're going to take a look at, right, as an engineer, how do I interface and interact and install some of these pre-built automations that Itential is providing out of box? So within the Admin Essentials application, you'll notice there's a pre-built section, right? As a user, I would come in here, and when I click on Browse, you will notice this opens up like the door to all the open source pre-builts that Itential already provides out of box, such as modifying VLAN configuration on Arista. But specifically for this demonstration, what I would like to focus on is some of the IP backhaul automation assets and artifacts that Itential is providing to their customers in order to accelerate the deployment as well as operations around the backhaul space, right? So when I click on this particular repository, you'll notice these are some of the common things that we're providing. There's a huge list of them that are actually available. So, in addition to actually doing configuration management on some of these assets, whether it's Cisco, Juniper, or even Nokia, when I type in ZTP, there's another flow that it's actually made available to our customers to leverage right out the gate, right? The goal is, how do you go faster? How do you go address all the issues as well as the innovation happening within the backhaul market? So as you can notice, as an engineer, you would come in here, you have the ability to install it. And I will give you an example of how an engineer would come and deploy or install one of the pre-built automations addressing the port deployment on a Nokia switch. So let's go take a look at that, right? So when I look for port, you'll notice this automation shows up. So as a user, I have the ability to install it. So when I click on the install, it actually goes and installs the entire set of artifacts that Itential provides out of box in order to drive that set of automation. So when I click on view, let's take a look at what that entails. So on the right-hand side, as part of that package, as part of that pre-built package, you'll notice we provide MOP templates, which are the pre-checks and the post-checks, as well as some of the configuration model, which is data-driven. In this case, we're leveraging Jinja2, as well as TextFSM, transformations, which actually help our customers address all the data transformation that need to happen between systems. So if you're actually procuring and federating data from your OS's BSS system, how does that pipe into the actual automation that is driven within the network? And finally, as you can notice from a workflow perspective, right, these are some of the modular and reusable automations that Itential provides out of box in order to go do specific atomic transactions within the network, right? These could be stitched together in order to actually address a use case. So in this case, what I'm actually going to do is click on the port deployment flow to kind of show you what that looks like for an end user, right? So as you can see, within the particular automation canvas in the middle, you'll notice there are a lot of boxes here, right? This embeds and includes all of our best practices that Itential actually provides out of box. So there's a lot of fallouts involved here, as well as a lot of transitions that enable you to make sure that you can do this in an autonomous fashion. So all the purple boxes that you see represent some of the modular atomic things that you can stitch together, and it has already been done on behalf of the customer here. That comes as part of the package. Specifically for this particular automation, it does a lot of pre-checks. It will actually go provision the port. It will also address what will be shown to the actual user as a result of what change was made within the network, right? So what I'm going to do is actually kick off this automation from within this particular platform. So when I actually click play, as a user, you could expose this via an API, as Morgan mentioned, to an OSS or BSS platform, or even pipelines that require port deployment on a backhaul switch or a CSR router, right? They can actually invoke these automations via an API. For the purpose of this demonstration, I'm actually going to provide a payload that looks like this, right? And this could be federated across multiple different systems. We could integrate into IPAM system to actually pull the IP addresses and also get information from things like, OSS system with respect to, what exactly the customer actually wants within the network, right? So before I actually kick off this automation, I would like to go into the configuration manager to kind of show you how we actually federate these devices, and we will take a backup on this device before we invoke a change within it, right? So for the purpose of this demonstration, we're actually going to be modifying the CSR ALU device. On the left-hand side, you'll notice there's a long list of devices that we're federating across multiple different orchestrators, controllers, as well as DevOps tools, right? So in this case, as a user, I have the ability to load live configuration on this particular device, and you'll notice there's already an existing port on here, but we're going to add a new one, right? But before we do that, let me go ahead and take a backup here, right? So let's call this pre-check 3, and let's go ahead and create that. So while it's doing that, what I would like to talk about is, from our perspective, everything that I'm clicking on within the platform has an API on top of it. In addition to that, it can also be stitched together as a drag and drop asset within the automation canvas. So, this becomes a reusable asset for the entire organization. So now that I have successfully created a backup called pre-check 3, what I would like to do is actually kick off the automation, that I just downloaded as part of the pre-built package, right? So let's go ahead and do that. We're actually going to do that against the CSR ALU2 device, and we're going to create a brand new port 113, right? So let's go ahead and start that, and let's take a look at what that automation looks like, right? So in the background, when a user, a pipeline, or an OSS BSS system kicks off an automation, this is what it looks like in the background, right? This is what the customers get. It's very operational. You can run this immediately on your infrastructure to get that acceleration towards your backhaul automation initiatives. So as you notice, there's a lot of atomic automations being stitched together. Specifically, this piece over here, as you notice, that's also a child automation. So when I dive into it, absolutely best practices, fallouts, all engaged, error handling. But as you notice, as we go through the flow, the last step is to actually set the native configuration onto the device. So we audit everything that happens within the platform here. So anytime you run an automation, anytime you invoke and create a backup, all of that is logged, so you can audit and actually use that as a way to justify some of the automation being created, and also make sure that only the right resources are requesting things in the network at the right time, right? So we capture incoming parameters, outgoing parameters, etc. All right, so now that we have successfully incurred a change within the network, I am going to go back to our configuration manager application in order to do another backup, right? Let's go ahead and call this Postcheck 3. And once the Postcheck is complete, what I'm going to show you is we can diff these backups to actually show you the change that was made onto that particular cell site router, right? So let's go ahead and select the pre-check here. And as you can see, I have the ability to compare against a live configuration on the device, or I can choose other backups that I might have taken in the past, right? So specifically, the one that I took for the Postcheck is right here. And when I load the diff between these two configurations, you'll notice we have successfully added port 113 onto that ALU device, which is a CSR within the IP backhaul network, right? So as you can see, engineers, the backhaul team members can rapidly leverage and operationalize the pre-built automations that Itential provides in order to drive all these sorts of changes that are required to provide these services, such as 5G slicing that traverse these sort of domains and networks. Right. So next thing we're going to talk about today, and the next part of the demonstration is going to be focused on config compliance. Right. How do you make sure that you have a compliance strategy across your entire backhaul network? So as part of this configuration manager application, we have a sub app that is called Golden Configuration. So what I'm going to do is pull up this cell side backhaul compliance Golden config that we have created here. So Itential takes a modern approach where on the left hand side you'll notice it is a tree-like structure, right? So this is how you might have your backhaul sites actually segmented. Whether it's done based on region, whether it's done based on role, it is completely configurable. So as a user, you can come in here and start identifying, hey, do you want to actually do the compliance strategy based on the role of a device within your network or based on the markets that you're addressing, right? At what level do you want that compliance? But one interesting thing that I would like to show is starting from the base. This is where an engineer would come in and define what is actually required on every single CSR router within the entire network, right? Doesn't matter whether it's in Northeast, Southeast, etc. So you'll notice, natively, you can start defining some of these configuration that are golden and best practices. At the same time, you have the ability to also leverage things like Jinja 2 templating within our application that help drive the whole concept around model-driven as well as data-driven compliance, right? The next thing I'm going to show you is as we kind of go through the segments, and if I dive into the Atlanta branch within Southeast, and when I click on the configuration, every set of configuration top to bottom is inherited. So anything that the network engineer might have defined as global for every cell site gets propagated down to any sub-node level, such as Atlanta within the Southeast, in this case, right? And it's color-coded, so you can actually see this is Southeast specific configuration, which is to push router, whether it's ISIS, BGP, etc. At the same time, when I continue scrolling down all the way to the bottom, only the Atlanta node has a segment routing piece of configuration, right? Because that might be the only market that you might want to set segment routing on top of these cell site routers. So as you can notice, right, this is the best way for our engineers to actually define the best practices. So you actually keep a standardized way of not only onboarding newer asset as part of your ZTP plan, but also your brownfield network where they have the ability to make sure that folks are not making bad changes into the network impacting services, right? So that is a more of a proactive approach that customers can take by leveraging, Itential's config compliance application. So once you have actually defined some of these configuration as golden, you also have the ability to define, how do you actually generate the config for us to actually run the compliance against, right? It's completely data-driven because each market might have a different set of data, different set of integrations that we actually pull the data from as a source of truth, right? So the combination of our automation capability as well as compliance capability enable our customers to make sure that their entire network is in compliance at all times. So more on that, right? So once you have actually defined your gold standard policies, as you see here, it's time to actually start adding devices, right? So as I mentioned early on, everything that I'm clicking on is also available via an API or one of those green boxes that you might have seen in the automation canvas, which represent our automated tasks, right? So what I'm going to do as part of this demonstration, there's already a device here as part of the Atlanta region. I'm actually going to add a new CSR device. So as you can see, we dynamically federate these from multiple different controllers and orchestrators and DevOps tools. Let me look for a CSR device here, right? So let's go ahead and add the CSR XR1 to this particular region, apply, and you'll notice it executed compliance on it, right? So as a user, I have the ability to view, what is out of sync or what is out of compliance on this device that's not making it service ready. So these are all the things that are actually missing on the device, whether it's interfaces, BGP router configuration, segment routing configuration. So as a user, I have a view of, hey, for me to actually bring this particular cell site router into compliance and make it service ready, I have to push all of these changes. whether you push these changes one by one, right? As a user, someone can come in and add these lines to this particular device or multiple sets of device at scale. Or you can do that programmatically via our pre-built automation. So to Morgan's point, we want to make sure that we're providing all of these assets out of box. So our customers can go as fast as they can to make sure that their network is compliant to its fullest capability, right? So I can click add on here and move forward. And as you can see, right, I can apply it, but in the background, based on the severity of some of these errors, you can have a approval process where network engineers or operation engineers get to approve changes that go into a network, right? So that is part of the entire orchestration strategy that also Morgan talked about. But as you can see, like this is a basic chart that actually tells you how compliant is your device. So that was our entire concept around, how Itential helps our customers drive compliance across your, IP backhaul network, whether it's one site or whether it's 100. We have done this at scale for multiple of our other customers. So now on to the last part of the demonstration, which focuses on, hey, once I have my device onboarded using the pre-built automation as part of the ZTP program, then I have day 0, day 1 configuration being pushed onto these devices, which are, in compliance with your gold standards where you define here. The last step is, hey, now their device is service ready. How do I make sure that changes don't take it down, right? So the whole concept around monitoring system and service assurance system sitting on top of your network assets, and how do we enable the entire closed loop to fill out that life cycle of these assets, right? So last part of the demonstration is going to be focused on the operations manager application, right? So as part of this demonstration, what I'm actually going to do is we have created an internal automation to do a port status change on a CSR router, right? And we're actually going to bring a port down, and we're going to watch that alarm show up within the Zabbix dashboard. And at that point, Zabbix would actually create an event within a Kafka bus, which will invoke an automation within Itential, right? So that kind of goes to show that not only users can kick off automations from within Itential's platform, but also because we expose APIs as well as trigger based on events via message buses, etc. That kind of opens up the possibilities where multiple different external systems can leverage all the pre-built automations that Itential is providing as a service, right? The concept is, hey, we have all these automations baked in within the platform. If a network slice is required, we expose these automation as an API that somebody else can actually orchestrate, right? So let's go ahead and do that. So as the last part of this automation and as the last part of this demonstration, I'm actually going to kick off this automation here, particularly to encourage change onto a CSR router, right? So you'll notice there's an interface name, and I'm going to change the status down. So as soon as I run that, it actually kicked off an automation. But before I jump to that automation, I actually want to quickly talk about, within the Ops Manager application here, there's a closed loop automation, right? As a user, you have the ability to define which automation you want to expose to the rest of the world or even internally. But on the right-hand side, there are several different triggers. So when I add the triggers, you'll notice there are 4 different types. It could be an API/webhook. You could schedule some of these compliance automation on your entire backhaul network. It could be a manual occurrence where someone comes in and fills out a form to request a service in your IP backhaul network. And finally, event-driven, right? Which is what we're exercising today as part of the demonstration today, where Zabbix is going to post an event and we're going to trigger off of that. So just quickly wanted to highlight that. And now that we have kicked off that automation to bring the port down, when we go into Zabbix, it takes a few additional seconds for it to realize that the port is actually down. But when it does, you'll notice there's a problem statement, right? There's a alarm that shows up in Zabbix. So at this point, Zabbix has dropped an event within the Kafka bus, which should have kicked off an automation within the Itential automation platform. So let's go back here. And let's go to the job manager where we should see an automation being triggered. So as you see, the closed loop automation was triggered based on the event, the alarm that was created by Zabbix. So when we go take a look at this particular automation, basically the first step is for us to review what that Zabbix alarm is. And as a user, or even programmatically, I will have an option to remediate the issue that happened on the cell site router, which is a port down event. or I have the ability to run pre-checks and post-checks that are also pre-built automations that Itential provides to capture all the information about the CSR and publish that within a repository or update a ticket so network engineers can take a look at it, right? So the purpose of this demonstration, let me go ahead and work this task based on my role-based access control permission. So when I work this task, as you notice, this is exactly what was captured by Zabbix. It was a port down event on loopback 0 on this particular host. And what I'm going to do as part of this next step is I'm going to remediate. So when I run the remediate flow, when I go into visualize, you'll notice it automatically understands and it takes this branch to actually go and undo the shutdown configuration on that device, right? So at this point, we have successfully done so, where if I go into here, it actually went through these steps and we have successfully omitted the shutdown line from the device, right? So everything is captured within the platform. So now the next thing I'm going to do is go back to Zabbix and see if this particular problem is resolved and this status should go into the resolved state. Again, it takes an additional 5 to 10 seconds for Zabbix to realize. And as you can see, we have successfully resolved the issue in an autonomous fashion. So that was the whole concept around how Itential as a platform in combination with its integration as well as pre-built automation enables our customers to drive, automation, IP backhaul automation and network changes at scale, inclusive of some of the closed loop activities that need to happen from a day two to day end perspective, right? So that was the actual end of our demonstration today, and I would like to hand it back to Morgan so he can talk about the rest of the presentation. Thank you.
IP backhaul device is using some of the components of the pieces that Karan was showing you. At the moment, we're working with these service providers to optimize the automations so that they can evolve their capabilities and better accelerate some of the 5G projects. And the results have been very positive. We've seen them realize major reductions in manual effort and acceleration of some of their projects, which has enabled one customer to establish a market-leading position in 5G. The solution, it's designed to address today's engineering and operations challenges, while it's providing a foundation for the future-facing capabilities like 5G transport network slicing and closed-loop operations, as well as support for physical, virtual, public cloud network functions. At this point, we're going to take a couple of minutes to answer questions. You still have a couple of minutes to put your questions in if you would like. But I'm going to transition over to the questions. One of the questions was, what happens if I want to introduce a new vendor into the mix? One of the things I think that a number of our customers have expressed is a desire to start to bring new vendors into the backhaul. I think, at least in some of the markets, the backhaul business has been dominated by a couple of vendors. And with these new technologies going in, the folks see an opportunity to introduce new vendors. And the ways that we can help to facilitate that, there are a couple. One is our philosophy has always been around rapid integration. So the ability to support new vendors, to support new technologies is something we focused a lot of energy on. And so it's really simple to add new vendors into the mix. The second thing is really a function of how you design the automations. We take a philosophy of designing a very modular style approach to doing the automations, so that when a new vendor comes in, you can simply customize those modular pieces that are vendor specific, and you can retain all of the rest of the automation logic that existed before, so that you do have the ability to pretty easily introduce new vendors and also to develop really powerful automations to support migration of traffic and circuits between the vendors. Next question is, how does this system scale? Is there a limit on how many devices you can automate? One of the things that has I think, been really fun as an Itential person who's been here for a long time is to see the deployments grow pretty significantly. So for one customer, for example, in 2020, they were automating in the millions of transactions a month. This year, I think they're going to be approaching 200 million transactions that they're automating. This is for over 100,000 devices. And so from a platform standpoint, we really have prided ourselves on the ability to scale. And so we offer a number of features and capabilities around how do you scale for higher transaction throughput? How do you do a more distributed model so that you can move towards, in some cases, global international networks for automation? And it's performed well. So really our answer to scaling the solution is around defining the architecture in such a way that you've got the right performance and availability. But in terms of the capability of the platform to handle load, we've been really happy with how we've been able to scale. One more question, and then I think we'll wrap up. Does the solution work in an environment that is moving from private cloud and physical devices to a hybrid model with more public cloud? Yeah, actually, there are a number of our customers that we're working with that are doing just that. We've seen, most of us have seen the announcements from folks like AT&T or others that are starting to look towards Azure or AWS or Google Cloud Platform as the environment that they're using to deploy some of the RAN functions and some of their edge functions. And one of the things that we didn't talk about too much in the session was really around the integration layer of the Itential platform. What we've done is create this rapid integration capability where we can work equally well in physical environments, in cloud environments, in public cloud environments. So if you go to our developer site and take a look at the open source adapters that are up there, you'll see we've already got a lot of coverage for things like Azure and for AWS and Google. And we continue to increase our coverage of those. And our customers use the tools that we provide to them to auto-generate the integrations for some of the other systems. So I think one of the clear advantages that we've been able to demonstrate in the market is regardless of the target domain that we're working in, we can provide a similar level of functionality and capability across all of those. So the things that Karin showed today around configuration management, around compliance, around closed loop automation, those will work the same, whether the target domain is cloud, container, bare metal, physical device. Okay, I think that'll be the last question for today. I want to thank you all for your participation and for your engagement. I hope you found the webinar to be insightful and valuable. If you have additional questions or you want to learn more, you can contact us at the email that's listed, or you can visit our website. Thanks once again, and have a great day.